Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, Power BI with AI and advanced analytics. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: how does Power BI identify key influences in a dataset? Power BI uses statistical analysis and machine learning algorithms, like logistic regression or decision tree models, to determine which factors have the greatest impact on a selected outcome. It examines each feature, column, individually and measures its effect on the target variable, considering correlations and predictive power. The visual ranks influences based on their relative importance, showing the features that most strongly explain variations in the outcome. Power BI also calculates the direction of influence, indicating whether an increase or decrease in a factor increases or decreases the target outcome. Second question: explain the difference between top-down and bottom-up decomposition in the decomposition tree. Top-down decomposition starts from a high-level measure, example total sales, and breaks it down into contributing factors step by step, allowing users to drill into the most influential dimensions first. Bottom-up decomposition begins with individual elements or dimensions and aggregates them upward to understand their contribution to the overall measure. Top-down is ideal for root cause analysis, while bottom-up is suitable when you want to understand how smaller elements collectively impact a total. Power BI allows users to interactively explore both methods, giving flexibility to analyze data from different perspectives. Third question: can AI visuals handle categorical and numerical fields together? How? Yes, AI visuals in Power BI can handle both categorical and numerical fields, but the type of analysis may differ based on the field type. Categorical fields are used to group or segment data, example region, product category, while numerical fields are used to measure or evaluate outcomes, example sales, profit. Power BI algorithms automatically treat categorical variables as discrete segments and numerical variables as continuous factors when calculating influence. This combination allows the key influences visual to identify patterns across both types, such as which product categories, categorical, and pricing levels, numerical, drive high revenue. Fourth question: how would you use key influences to determine factors driving high sales in a dataset? First, select high sales as the outcome variable in the key influences visual to focus the analysis on the target measure. Include all potential influencing fields such as region, product category, sales channel, and marketing spend to allow the model to identify patterns. Analyze the results to see which factors have the highest influence score, paying attention to both the strength and direction of influence. Use the insights to guide business decisions, such as allocating marketing budget to high-impact regions or optimizing product strategies based on key drivers. Fifth question: how would you structure a decomposition tree to analyze why a product category's profit dropped despite high sales? Start with the product category as the top node to isolate the segment of interest. Add relevant dimensions like region, store, salesperson, discount, and cost as child nodes to explore potential contributors to reduce profit. Drill down through each node to identify the specific factors causing profit decline, such as high discounts, increased costs, or poor performance in a specific region. Optionally, include filters or slices to focus on specific periods, product lines, or markets to refine the analysis. Sixth question. AI visual shows unexpected influences. How would you validate these results before presenting to stakeholders? Cross-check the results by creating supporting visuals, such as bar charts, scatter plots, or measures, to confirm the patterns suggested by the AI visual. Examine the underlying dataset for anomalies, missing values, or outliers that may have skewed the AI model's findings. Test the results using alternate metrics or subsets of the data to see if the influences remain consistent. Prepare a clear explanation for stakeholders, emphasizing that AI visuals show correlations and influences, which may require business context for full interpretation. Seventh question. How do slices and filters affect AI visuals? Slices and filters limit the dataset available to the AI visual, so the key influences or decomposition paths are calculated based on the filtered data only. This allows users to perform segment-specific analysis, such as examining influences for a particular region or time period. However, extreme or overly restrictive filters may reduce the dataset size too much, leading to less reliable or insignificant results. Power BI updates AI visuals dynamically when slices or filters are applied, enabling interactive, real-time exploration of influences and decomposition paths. Eighth question. How does Quick Insights detect patterns and correlations automatically? Quick Insights uses automated algorithms to scan the dataset for statistical patterns, trends, outliers, and correlations between fields. It examines numerical and categorical variables to detect relationships such as high correlation, clustering, or unusual distributions. Power BI applies techniques like variance analysis, regression, and anomaly detection to identify significant insights. The results are presented as visual summaries, cards, charts, that highlight trends, comparisons, and potential key drivers in the data. Ninth question. What are the limitations of Quick Insights for large datasets? Quick Insights may struggle with very large datasets because automated analysis can be slow or may time out. It only detects basic correlations and patterns. Complex relationships or multi-factor dependencies may not be identified. Insights are exploratory and may include false positives or spurious correlations if the data is noisy or incomplete. Quick Insights cannot be customized in terms of which algorithms or variables to analyze, limiting advanced analysis options. 10th question. Quick Insights finds a correlation between marketing spend and revenue. How would you verify it using visuals or DAX? Create a scatter plot of marketing spend versus revenue to visually inspect the correlation and check for linear or nonlinear relationships. Use DAX measures to calculate correlation or covariance, e.g., CORREL, table, marketing spend, table, revenue, to quantify the relationship. Analyze the data over time periods or segments using line charts or slices to ensure the correlation holds across different contexts. Compare the findings with other KPIs, such as ROI or conversion rate, to validate business relevance. 11th question. Quick Insights produces patterns that don't make sense. How would you debug or refine the dataset? Check the dataset for missing values, duplicates, or outliers that could distort automated analysis. Examine the data types and formats of each column. Incorrect types can mislead the algorithms. Apply filters or pre-processing to remove irrelevant data or focus on meaningful segments. Rerun quick insights after cleaning, and cross-validate results using other visuals or manual calculations to ensure accuracy. 12th question. How can quick insights results be used in a dashboard for executive storytelling? Highlight the most important trends, correlations, or outliers as summary cards or KPIs on the dashboard. Combine quick insights visuals with filters and slices to allow executives to explore key patterns interactively. Use quick insights as a starting point, then add contextual explanations, annotations, and comparisons to create a narrative. Integrate insights with other AI visuals or forecasts to provide actionable recommendations rather than just descriptive patterns. 13th question. How does Q&A interpret ambiguous queries, and how can you improve accuracy? The Q&A visual uses semantic interpretation, meaning it tries to match user words to dataset fields, measures, and synonyms. When queries are ambiguous, it chooses the closest match based on linguistic similarity and past training patterns. It attempts to infer intent from sentence structure, but ambiguous words like profit, income, or margin may map incorrectly if the model lacks strong metadata or synonyms. You can improve accuracy by building a strong semantic model, which includes defining synonyms, formatting data properly, and ensuring fields have meaningful names. You can add phrases, terms, and suggested questions in the Q&A setup, helping Power BI correctly interpret vague or domain-specific queries. 14th question. What is the role of synonyms, phrases, and term mapping in Q&A? Synonyms help Q&A map multiple user terms to the same dataset field, allowing queries like profit, income, or earnings to return results from one net profit column. Phrases allow Q&A to understand complex language structures, such as mapping revenue last quarter to a measure like revenue LYQ. Term mapping ensures that industry-specific or company-specific terminology, example, GMV, to total sales, correctly links to the underlying field. Together, these tools make Q&A more flexible, accurate, and capable of understanding natural human language, even when it varies from dataset naming conventions. 15th question. Can Q&A work with dynamic calculations like measures or calculated columns? Yes, Q&A fully supports measures because they are semantic model objects designed for dynamic calculations, which Q&A can interpret and present in user queries. Calculated columns are also supported, though they behave as static values, and Q&A can return results based on them, similar to how it handles normal fields. You can improve usability by giving measures friendly names like total revenue, enabling Q&A to pick them up easily when users type similar phrases. However, very complex or nested DAX measures may confuse the Q&A engine unless clear synonyms or terms are added to guide its interpretation. 16th question. Q&A returns incorrect results for top products by income. How would you fix it? First, check if the dataset has a field called income. If not, create a synonym or map income to the correct measure such as net profit or sales amount. Ensure that the relevant metric, example profit, is defined as a measure, not a column, so Q&A can correctly aggregate it when calculating top results. Improve the semantic model by adding synonyms like income is equal to revenue, income is equal to profit, depending on business meaning. Validate the query by testing alternate phrasings like top 10 products by profit to confirm whether the Q&A misinterpreted the term or the ranking logic. 17th question. How would you configure Q&A to understand industry-specific jargon or abbreviations? Use the synonyms pane to map abbreviations, example, AOV, GMV, CAC, to their corresponding measures or fields in the dataset. Add custom phrases so Q&A can understand multi-word expressions such as customer acquisition cost, then CAC, or average order value, then AOV. Update the model's Q&A linguistic schema so that domain-specific words derive from the correct fields, helping Power BI interpret industry-specific concepts. Test real user queries from stakeholders and add missing synonyms or terms iteratively to ensure the model fully understands your organization's language. 18th question. How do you handle multi-part queries in Q&A? Example, show total revenue by region and compare with last year. Q&A interprets multi-part queries by breaking them into components, metric plus dimension plus comparison, but it works best when clear measures like total revenue and revenue lie exist. Create a year-over-year, YoY, or last year measure using DAX so Q&A can correctly answer comparative requests. Add synonyms like compare, vs, last year, and map them to the respective measures for easier interpretation. If Q&A struggles, you can break the query into smaller chunks or create a featured question that explicitly performs the comparison, improving user experience. 19th question. Explain how Power BI's forecasting uses exponential smoothing and confidence intervals. Power BI forecasting uses exponential smoothing, ETS, which assigns higher weights to recent observations and lower weights to older ones. This helps the model adapt quickly to recent trends. It automatically applies additive or multiplicative smoothing depending on the shape of the trend and seasonality patterns detected in the dataset. The model generates confidence intervals by simulating upper and lower boundaries of possible outcomes based on historical variability, giving users a range of expected future values. These intervals help identify the uncertainty in predictions, allowing users to differentiate between normal fluctuations and genuine risk areas in future projections. 20th question. How does seasonality affect forecasting results, and how can it be adjusted? Seasonality significantly influences the ETS model because repeating patterns, weekly, monthly, quarterly cycles, affect how the forecast curve is formed. If seasonality is detected incorrectly or not detected at all, the forecast may appear unstable, flat, or overly fluctuating. Power BI allows users to manually set seasonality when automatic detection fails, example forcing a 12-month cycle for annual sales patterns. Adjusting seasonality ensures that known business cycles, festivals, quarters, promotional periods, are accurately represented in the forecast output. 21st question. Forecast shows unexpected spikes or outliers. How would you validate the model and data? First, check for data quality issues, such as missing dates, duplicated entries, incorrect values, or abrupt data entry mistakes that may produce artificial spikes. Validate whether the spikes align with real business events, product launches, holidays, campaigns. If not, treat them as anomalies and clean the data. Review the time granularity, day or month or year. Too granular data can amplify noise. Adjusting the frequency can stabilize the pattern. If required, separate outliers using anomaly detection, remove them, or categorize them before applying the forecast to ensure a smoother and more reliable trend line. 22nd question. How do Power BI forecasts behave when slices are applied? Forecasts recalculate dynamically based on the filtered dataset, meaning the model runs again using only the visible data left after slices are applied. Applying slices that reduce data length, example selecting only 3 months, may disable forecasting because Power BI requires a minimum data volume to build a time series model. Slices can change the trend direction and seasonality structure, meaning the forecast may look very different depending on the filters applied. Forecast confidence intervals may widen significantly on a filtered view because reduced data creates more uncertainty in predictions. 23rd question. How do you ensure forecast reliability when data has irregular time intervals or missing periods? Power BI forecasting works best with consistent time series, so when data has gaps, the model may misinterpret them as sudden drops or incorrect seasonality. To improve reliability, you should fill missing dates using date tables and join them using a proper relationship. Use interpolation techniques in Power Query, example fill down, averaging, or custom logic, to handle missing values before enabling forecasting so the trend line remains stable. If intervals are highly irregular, example transactions instead of monthly summaries, first aggregate data to a stable granularity such as daily, weekly, or monthly to ensure the model detects patterns accurately. For very inconsistent datasets, consider using Python, R forecasting scripts because they allow explicit handling of missing periods and can model irregular or uneven time series more effectively than the built-in forecasting tool. 24th question. How does Power BI detect anomalies in time series datasets? Power BI uses statistical forecasting models based on exponential smoothing and moving averages to estimate an expected value for each point in a time series. Once the expected baseline is calculated, Power BI generates an upper and lower confidence boundary and flags any point outside this band as an anomaly. The algorithm also considers local patterns, such as seasonal trends, periodic spikes, and multi-level fluctuations, instead of treating the series as a flat distribution. Power BI continuously evaluates data density, trend direction, and seasonality to ensure anomalies are not misclassified due to natural variations in the dataset. 25th question. Explain sensitivity versus expected value in anomaly detection. Expected value represents the model predicted normal value for a specific time point, calculated using trend, seasonality, and statistical smoothing. The expected value defines a reference baseline against which actual observations are compared to determine whether something is unusual. Sensitivity controls how easily the model flags anomalies by adjusting the width of the confidence interval around the expected value. Higher sensitivity results in a narrow confidence band, causing more points to be flagged as anomalies, whereas lower sensitivity results in fewer anomalies by widening the band. 26th question. How is anomaly detection different from simple outlier identification? Traditional outlier detection treats extreme values as unusual based on global distribution rules such as Z-scores or IQR, without considering time-based patterns. Power BI anomaly detection is time-aware, meaning it evaluates deviations in the context of trend direction, seasonality, and expected time-specific behavior. Outlier detection generally works on static datasets, whereas anomaly detection is designed for continuous time series with dynamic behaviors. Anomaly detection also provides root cause analysis, enabling users to analyze dimensions influencing the anomaly, which simple outlier rules cannot offer. 27th question. How would you detect anomalies in monthly sales data and interpret the results? First, place the date field on the x-axis, the sales measure on the y-axis, and enable anomaly detection in the analytics pane of the line chart. Adjust sensitivity to control how many anomalies the model detects, especially if the data contains natural seasonal peaks. Power BI will highlight the anomaly point and display explanations, showing which attributes, example region, product, customer segment, contributed to the deviation. Interpretation involves comparing the anomaly with expected seasonal behavior and using root cause insights to understand whether operational, marketing, or inventory factors drove the deviation. 28th question. How can anomaly detection be integrated with alerts using Power Automate? Anomaly detection results can be connected to Power Automate by exporting the flagged anomaly data through a measure, table, or summarized dataset. You can create a scheduled or triggered Power Automate flow that checks whether the anomaly condition is met and sends notifications via email, Teams, or mobile alerts. Using the Power BI Data-Driven Alert connector, flows can trigger messages when thresholds are crossed, effectively turning anomalies into automated monitoring alerts. This integration allows proactive business responses, enabling teams to detect unusual trends in real time and act before issues escalate. 29th question. How do slices and filters affect anomaly detection visuals? Slices and filters modify the underlying time series, which may change the model's trend and expected value calculations dynamically. Removing periods or focusing on specific segments, such as a single region, can cause anomaly points to appear or disappear due to changes in data density and seasonality. If filters reduce the dataset too much, Power BI may not detect anomalies because the model requires a minimum number of data points to identify patterns reliably. Slices can help isolate anomalies within specific categories, enabling more accurate contextual analysis for different business dimensions. 30th question. Compare key influences versus quick insights. When would you use each, and why? Key influences is ideal when you want to understand the drivers behind a specific outcome, such as why churn increased or which factors lead to high sales. It provides statistical explanations and compares subgroups with the overall dataset. Quick Insights is best for rapid exploratory analysis because it automatically scans the entire dataset to find correlations, anomalies, trends, and outliers without defining a target metric. Use key influences when you need explainability and interpretability of cause and effect relationships, especially when presenting to business stakeholders. Use quick insights when you need broad discovery of hidden patterns and want a fast, automated way to generate analysis ideas before deeper modeling. 31st question. Dataset has multiple hierarchies. Which AI visual or method would you use to identify root causes of low performance? The decomposition tree is the best AI visual because it allows you to break down performance step by step across hierarchies and automatically identify the most impactful branch using AI splits. Users can explore data interactively by drilling from region to state to city to store, revealing where revenue drops or performance deteriorates the most. The AI-driven, high-value or low-value Split helps identify the dimension or hierarchy level contributing significantly to the performance issue. If deeper factor analysis is needed, the key influences visual can complement the tree by highlighting non-hierarchical drivers such as customer type, product category, or time period. 30-second question. How can Q&A and AI visuals complement each other for exploratory analysis? The Q&A visual enables users to ask natural language questions like, "Why did sales drop last month?" and quickly generate starting insights or relevant charts. Once initial patterns are discovered using Q&A, AI visuals such as key influences or decomposition tree can provide detailed statistical explanations and structured drill downs. Q&A allows free-form exploration, while AI visuals provide validated, model-driven insights, helping convert casual questions into analytical evidence. Together, they create a seamless workflow where intuitive questioning leads to quantified insights, which can then be refined and validated using deeper AI models. 33rd question. How would you validate AI-driven insights before presenting them to stakeholders? Cross-check AI results using supporting visuals, such as bar charts, scatter plots, or trend lines, to confirm that the patterns are visible in raw data. Validate statistical findings using DAX calculations, manual filtering, or grouping to ensure the AI model is not misled by outliers or data imbalance. Review the data quality, checking for missing values, incorrect categorization, or skewed distributions that might distort AI results. Seek domain expert input to verify whether the identified patterns make business sense and align with operational knowledge or historical behavior. 34th question. AI visuals are slow on large datasets. How would you optimize performance? Reduce dataset size by implementing aggregations, incremental refresh, or pre-aggregated tables, ensuring that AI visuals process fewer rows. Limit the number of fields used in AI visuals by removing unnecessary columns, reducing cardinality, or creating grouped categories for high cardinality fields. Optimize data modeling by ensuring proper relationships, star schema design, and removing unused measures or calculated columns that slow computation. Use direct query with aggregations or import mode optimization so that AI visuals compute faster without scanning the entire underlying dataset. 35th question. How would you combine forecasting, anomaly detection, and key influences in a single dashboard to provide actionable insights? Use forecasting on line charts to show future trends, peaks, and expected ranges, helping stakeholders anticipate performance and plan proactively. Layer anomaly detection to highlight unexpected spikes or drops in recent periods, indicating where immediate investigation is required. Place key influences alongside these visuals to explain the underlying causes of anomalies or significant trend changes by identifying factors driving the shifts. Together, this combination creates a predict then detect then explain workflow, turning raw data into actionable business intelligence and enabling fast decision-making. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.